We will make start stop direct online or full voltage starting using the relays here. Electromechanical relays. As we notice, these are only DC. We are only simulating the magnetic conductors, magnetic switch, magnetic controllers, as what you call it, magnetic conductors. We are only simulating the operation because the relay here is similar to the magnetic conductor. Although we don't have the AC motor also here, but we have a DC motor. That is also a very good example to control a motor in single phase. The three phase can be possibly controlled. There is the lamps or even the motor. We just need 3 lines to simulate the power side of the motor. Okay, we need the power supply. Well, whatever is your standard, you can have this one up and down. We need the circuit breaker, so we will make this one as our circuit breaker, the detent switch, because this will latch. We need the stop or the reset. Okay. In start stop control, we have the stop normally close. We have the normally open to start or run. So this is stop or reset. This is stop or reset. This is run or on or start. And as we go further, we will extend the number of relays, number of contacts, number of auxiliaries. We are going to rotate this one. For some reason, the recorder cannot capture the right click of this one. But it is in the first video that you can see the rotation. How are we going to you can rotate this one angle 90, 180. You can drag this one, just highlight that one. Okay, we will start with the start stop control. This is step by step. So as we know, you can connect this one if this will become green, that one, and just connect them. It will turn green. You can straight this one later. Okay, you can straight this one like that. Just highlight. You can straight this one like that. You can straight the lines. Okay. In this example, we are going to try to simulate the start stop. As we know, this is the circuit breaker. or the auxiliary protection simulated by the detent switch. And we are going to label this one and this one with the same label, so they will function at the same time. So the label is, let's say, CB1, CB1. Okay, so if we are going to try that one, and you can see the hands, we have the turn on or start stop. Okay, see, the turn on simultaneously, but you cannot see the flow of current because that is normally open or initially open. So we need to turn that on also. So we will see. So remember, this is spring return. That symbol is spring return. We are going to press this one and release the pressure. This will turn off also. Turn on. Release the pressure. Turn on. Release the pressure. So in this case also, we are demonstrating that the current is flowing to the coil of the relay. So turn on. Okay. Turn on. Now we are going to expand the circuit or add a circuit. Yeah, we know that this will not latch the relay. Let's say relay 1. Because we need to have the latching contact or the sealing contact latching, this one, to make an independent path of this relay coil. Why? Because this is spring return. As long as you are going to release the pressure, turn on the CB first, no current flow will do the relay coil. So if this relay coil uses the auxiliary contact, we can have the independent path here. When we are going to release the pressure here, no more current will flow here. So remember, in parallel connection, you have two independent paths here. So we are going to parallel the auxiliary push button normally open and the auxiliary contact normally open together. Turn off. You cannot edit if you are not going to turn off. So parallel here, parallel here. Okay. Notice again here. See, why this one is not turning on? Because there is no label. So what should be the label here? If that is R1, we are going to label that one also as R1. Okay, right click. You can label this one or double click, label R1. So okay, in the laws of relay operation, magnetic switch, magnetic contactor, if this coil is labeled R1 and that is auxiliary contact labeled R1, that means this relay owns that one. So that magnetic contactor, magnetic switch, is the owner of this auxiliary contact. Okay, remember that the component description here, you can see the components here. There is a relay, are sets of contacts. For some reason also the component description cannot view, but we will insert this one. Some in German, some in English. Now, if we are going to try to add another contacts here. Let's say copy this one, paste. So let's say another normally open contact. So the two contacts here will turn on together. Let's see. Okay. So this one is useless anymore, the push button, because once you turn this on, there are three independent paths. So one is here, one is here. So if the pressure is released here, of course you are going to release that one, because you are not going to turn that on forever. Otherwise, that is not a correct start-stop operation. So that's why we need the holding contact, latching contact, or sealing contact. How are you going to say it? But that is redundant. So we can use this one for another purpose. So maybe we can add a signalation here. Signalation or indicator. Yes, lamp. That means it is functioning together with the relay. Okay. Turn on the C bit, turn on this one. Release the pressure. This one is holding the supply of the relay, and this one is signaling that the relay is in operation, and that is controlled by another set of auxiliary contacts by the relay R1. You can label this one. Okay, stop or reset, and this one is start or run. Start or run. Again, circuit breaker on. Reset. Okay, so why this one is detent switch, so that you can make this one as emergency stop also. A regular stop push button is recommended also. So you can series another push button here. If you want the regular push button that is normally close contact at the same time spring return, just remove this one and add the auxiliary push button normally close without the latching operation or not detent. Okay, remember they have different function. So if you will have this one as your emergency stop, so and this one is the regular stop reset. That means we have this one as latching push button emergency stop. Usually this is a big push button, a mushroom type head push button. and this one is a regular size push button, red color, and this is usually green or black color in international standard. Now what we lack here is the, guess what? We don't have the thermal overload relay here, so we will add the thermal overload relay here. Okay. Now going back first to the numbers again. These numbers represents the lines. That one, line 1, the line here. If we are going to add another line here, say for example the terminal of the TOR, we will simulate the thermal overload relay as a D10 switch. One is normally open, we will place that one here. Let's say we will make another line here, and we need a buzzer. We need a buzzer for acoustic signal. You can add a lamp also if the acoustic signal is too loud. 5, 6, 7, 8, so this have 1. There are number 2 here, so that is line 2 because they are not aligned. We are going to align this one, so it will not make number 2, but it's not necessary. So see 1, 2, 3, 4, 5, 6. So these are the lines. Line 3, vertical line 4, vertical line 5, vertical line 6. And about the 1 and 2 in ISO or IEC standard, 1 and 2 are normally close contacts. See? And 3 and 4 are normally open contacts. In reality, if we have the magnetic contactor, they are labeled 13, 14 in some cases, and the next one, let's say this is 13, 14, 1, 3, 1, 4. This will become 2, 3, 2, 4. Or you just add 10, so it become 23, and so on. So you have, if you have another set of normally open contact, it will be 33 and 34. Usually for multi-contact contactor, you have also the extension contact 63, 64, 83, 84. As long as the last contact is 3 and 4, that is normally open contact. And the first digit usually is 1, 1 for the first set. The second set is maybe 22, 23, or other than this, they are different numbers. If the other one is 11, 12, the next one is 21, 22, or 31, 32. As long as the number, the last number is 1 and 2, that is normally close contact. So we'll remove this one, series. So if you are going to turn off a circuit, dominant stop is normally close. So this is dominant stop connection. This is dominant stop connection. They are in series with the coil. So this is how are we going to connect the emergency stop reset, TOR, thermal overload relay, and this one is not connected here, because otherwise it will defeat the purpose of the signal. So this will turn off, so no more supply here. So the supply is here, going to the buzzer. So you don't have to cut off the supply of the emergency alarm or the tripping alarm if there are troubles or overcurrent in the motor. Say we'll turn this on. So there are open connections because we are moving. You can delete that one. Okay. Now remember, we don't have labels here, so this will not function. This will not function because there is no label between the two. Okay. Turn off. Let's say OL1. OL1. They should have the same label. So they will act as one. So remember, in thermal overload relay, they have mechanism that will trigger the overheating of the thermal element by the bimetal thermal element bimetal strip. And okay, once the motor is in operation, we will simulate the motor later. So this is turning on the motor via another contact, let's say power contact. So we will simulate this one manually. So the supply here will be cut off. The supply will be here to signal the alarm. So that means we have a tripping action in our circuit. So what are we going to do? You don't have to reset the thermal overload relay. That is a wrong procedure. If there are tripping action, there must be trouble in the circuit. That means we are going to turn off the main circuit breaker. In this case, we have the auxiliary circuit breaker first. And repair the trouble. What causes the thermal tripping? Turn off. And at that time, we are going to reset the thermal overload relay. Go to the specification of the motor, go to the specification of the setting of the thermal overload relay. Okay, we will connect the motor. As we go on, there will be multi-contacts here and multi-relay. Where's the motor? Here's the motor. Okay, let's say we're going to use single phase. Rotate. The vertical power supply. Okay, we need again the circuit breaker. We will copy this one. Copy, paste, and you can rotate them together. Okay, yeah. We can have this one as our circuit breaker too, or CB main. We have here the circuit breaker, and we need the contacts. There is no description of power contacts here, that you can use the same contacts. So in reality, this is power contacts or heavy contact capable of carrying the current of the motor. And we will need this one also, thermal overload relay. The thermal overload relay inserts after the power contact. So this is the thermal element inside the thermal overload relay or overload relay. So power supply, circuit breaker, power contacts in series, thermal overload relay in series with a load. If you have some auxiliary monitoring devices here, you can add also in reality metering system or the auxiliary transformer, because usually in reality this is lower voltage than the motor voltage. So if this is 240 volts or 440 volts, 380 volts, the control is somewhere 110 volts, 220, 240 volts. So you need an auxiliary transformer after the main circuit breaker. The transformer is usually here, and you're going to connect that one to this one. Is, so let's say you have transformer here. Let's say we need a box. You don't have transformer here. Another switch here. Let's say transformer here. Output goes to the input of the auxiliary circuit. Okay, we'll continue. And this one. You can interchange whatever connection is there. R1, R1, the same, CB1, CB1. If you want this one as the main, let's say CB2. So this is independent from the CB1. So they have the same level. When this one auxiliary contact function, this one also will function. But one is to be changed as normally close. Because they will open when there is overload relay, overload or overcurrent. Do we miss something? We'll try. It will be indicated. So turn on. Let me say turn this one on. In reality, because this is the main and this is the slave. So again, we have imaginary lines here going here. Now the motor is turning on. Stop, normal stop. Okay. Turn on, emergency stop. You cannot turn that on because that is latched by emergency push button. Unless you are going to press that again, then restart. Okay. Let's say we're going to make trouble here. So what does it mean? The motor is in overcurrent. So the line here will have overcurrent. The bimetal element here will react for how many minutes or seconds depending on the setting, depending on the motor. Usually it's 20-25% of the full load current of the motor. Just refer to your local electrical code. Then what will happen here? This will react, of course not instantaneous. Remember, this will not trip by short circuit. This will trip on overload current, that is by increments, not instantaneous current. The change of overload current is not instantaneous but by increment. So let's say maybe inside 1 minute or after 1 minute, some overload thermal elements will react depending on the setting. So again, maybe 20-25% of the motor's full load current, more, that is 125% of the full load current to set the thermal overload relay button. Next, so this one will trip, so either we are going to press. So of course they will act as one. So this one is turned off, that is turning on. So if the circuit is within the operator's, of course within the operator's reach, so you can hear the thermal overload relay signal acoustic buzzer. So what you are going to do if you are the operator, turn off the main circuit breaker. So this is the main, that is the slave, so that will be turned off in reality. Do not reset the thermal overload immediately. I turn this off. Okay. See what causes the overcurrent. That is not a short circuit for sure. Ground fault, mechanical trouble, bearing, winding troubles, whatever causes that. So you need some skills here to test the motor, including the insulation, whatever what causes the overload, overcurrent. Let's say overcurrent or overloading at the mechanical side of the motor. Then that's the time you are going to reset this. You are going to review your setting based on the motor's current. Check the quality of the power contacts. Maybe one is not properly in contact. You have single phasing if you have three phase. So turn off the circuit. So we have now the start stop control. You can add text here. Start, stop. Control circuit. And you can have this one copy and change the to motor circuit, motor or power circuit. Or main circuit, as you name it. So this is the auxiliary circuit. Auxiliary circuit usually has a lower voltage compared to the motor and motor or power circuit. There again. turn on, turn on. Okay, you have the normal start stop. Okay, then turn on again, emergency stop, just in case there is this is applied in, let's say, conveyor. You are going to adjust something with the load. We are going for emergency stop and release again. Okay, and simulate the overload relay. So no more power. Why? Because that is turn off. Auxiliary is controlling that power contacts. So it is now open because the relay has no supply. The supply now is in the alarm system. You can have lamps also there. Turn off the right thing to do is turn off the main CB and see what causes the overcurrent. Turn off the whole circuit. That's the time you are going to reset the thermal overload relay if you are reviewing the causes of the overcurrent in the motor circuit. By step or increment operation. Single step, another step, next step. Okay, stop first. We are going to turn on the two circuit breakers. Next step. Auxiliary turn on. Next is the power. Release. Okay. Next. Reset. Then this one will release. Okay. Another one. Oh, sorry. Then release. Overload simulation. Turn up. Next. So this is now the alarm here. Then turn off the CB, the two CB. Okay. So do not reset this one until you can find the trouble of the overcurrent. As we go on, we are going to add some relays here. Two relays interlock, or forward reverse, next, or star delta. So we can also use the star delta control here because that is only a two-line circuit. And that's all for this video. Have a happy day. Thank you.